In the vast silence of the cosmos, every once in a while, something appears that completely shakes our understanding of the universe. Back in 2017, astronomers witnessed such a moment when a mysterious object slipped into our solar system, unnoticed at first, but unforgettable once its presence was confirmed. That visitor, later named Oumuamua, wasn't like the familiar comets or asteroids we've cataloged for centuries. It had come from far beyond the reach of our sun, from another star system, carrying with it secrets of a journey lasting millions, perhaps billions of years. For humanity, this was the first, undeniable evidence that objects from other star systems could and did find their way into ours. It was both thrilling and unsettling. Fast forward to the present, and history is repeating itself, only this time with even greater clarity. In 2025, our telescopes are tracking yet another strange interstellar traveler, one that is on course to pass through the inner regions of our solar system. Unlike Oumuamua, which caught us by surprise and was already on its way out by the time we spotted it, this new arrival has been detected early. That means we get a rare opportunity to watch, in real time, as a messenger from another part of the galaxy approaches the sun. To understand why this is such a big deal, we need to step back and revisit what made Oumuamua so extraordinary in the first place. When it was finally noticed racing past Earth's orbit, astronomers quickly realized it wasn't behaving like anything we'd ever seen. Normal asteroids and comets are trapped by the sun's gravity, endlessly circling in stable orbits. Escaping the solar system requires tremendous speed, known as escape velocity, about 42 kilometers per second if you start from Earth's distance. But Oumuamua was already moving at nearly double that speed, close to 87 kilometers per second, far too fast to ever be caught. Its trajectory wasn't the typical closed loop of an orbit, but rather a hyperbolic path, meaning it had simply swung by the sun and was now on its way back into interstellar space. That alone was enough to classify it as something unique, but there was more. It passed closer to the sun than Mercury, where its motion should have slowed under the immense gravitational pull. Instead, it mysteriously accelerated as if pushed by some hidden force. That baffling change in velocity defied conventional explanations and triggered a storm of debate among scientists. Was it outgassing like a comet, releasing jets of vapor invisible to our instruments? Or was it something entirely different? Perhaps even a technology-driven probe from an ancient civilization? The idea of aliens may sound sensational, but the truth is we still don't fully know. What we do know is that Oumuamua redefined how we think about cosmic visitors, and it set the stage for everything we're about to discuss with the new interstellar object now on approach. When astronomers first tried to study Oumuamua more closely, they quickly realized that the mysteries surrounding this object went far beyond just its unusual speed. Normally, when a comet dives close to the sun, the heat causes frozen gases locked inside its icy surface to escape in dramatic plumes. These jets of vapor create the signature glowing halo, or coma, and a long tail that points away from the sun. The push from this outgassing can alter a comet's speed and direction, and that's why comet trajectories often seem a little unpredictable. But here's the strange part. Oumuamua displayed none of these visual markers. There was no coma, no tail, no visible jet of gas or dust, and yet its velocity shifted as if something was actively propelling it forward. That was the first big scientific puzzle. If it wasn't behaving like a comet, then was it just a solid asteroid? Not exactly, because its brightness also defied expectations. Astronomers tracked the way sunlight reflected off the object and discovered that it wasn't reflecting consistently. Instead, the brightness would rise and fall in a repeating cycle every 7 to 8 hours, as though the object was spinning and showing us different sides. The only way to explain this kind of variation was if Oumuamua had a very unusual shape, long and stretched out, more like a cigar or pancake than a typical round rock tumbling through space. Even more intriguing was its surface reflectivity. It was far more reflective than most asteroids, which are typically dark and rocky, absorbing more light than they bounce back. This raised the possibility that Oumuamua was composed of something other than stone, maybe frozen nitrogen or some exotic ice that gleams brightly under sunlight. Yet the tumbling motion, combined with the lack of detectable gas emissions, opened the door for even bolder ideas. A few respected scientists suggested that perhaps this wasn't a natural object at all, but instead some kind of artificial construct, an interstellar probe, or debris from an advanced civilization. The alien hypothesis gained traction not because of wild imagination, but because standard physics simply couldn't account for all the data. Still, science requires caution. Most experts argued that unseen outgassing of invisible materials like hydrogen or nitrogen could still explain the mysterious acceleration, even if our instruments weren't sensitive enough to detect it. But whether natural or artificial, Oumuamua proved to be unlike anything we had ever observed before. Its strange trajectory, peculiar acceleration, reflective surface, and bizarre shape combined into a cosmic riddle that continues to spark debates today. More importantly, it left us with a realization. The universe is capable of surprising us in ways we never expected. And if Oumuamua was the first interstellar visitor we detected, it might only be the beginning. That idea became even more compelling when, just 2 years later, astronomers spotted another interstellar traveler heading straight for our solar system. The mystery of Oumuamua was still fresh in the minds of scientists and the public when in 2019, the cosmos delivered another surprise. This time, the discovery didn't come from a massive observatory, but from an amateur astronomer named Gennady Borisov. His careful skywatching revealed a new interstellar object on a hyperbolic trajectory, destined to swing past the sun before vanishing back into the depths of interstellar space. Unlike Oumuamua, which defied easy categorization and left us puzzled, this new object, appropriately named 2I Borisov, looked and behaved much more like the kind of visitors we already understood. Through telescopes, scientists could clearly see the fuzzy halo of gas and dust surrounding it, along with a tail extending out into the void. In short, Borisov was unmistakably a comet. That made it far easier to study, because astronomers could apply the physics. They already knew the heating of frozen ices, the outgassing process, and the effects of sublimation on its orbit. While Borisov confirmed that interstellar comets were real, it didn't ignite the same level of heated debate as Oumuamua. In some ways, it was reassuring, almost like the universe was telling us, yes, interstellar visitors exist, but not all of them are strange or inexplicable. Still, its arrival carried major implications. For centuries, humanity had observed the skies and never spotted a single confirmed interstellar object. Then, in the span of just 2 years, we had detected two, one incredibly strange, and the other perfectly ordinary. Statistically, that raised an exciting possibility. Perhaps interstellar objects are far more common than we once believed, and our telescopes were only just becoming capable enough to notice them. Yet while Borisov expanded our knowledge, it also reinforced how exceptional Oumuamua truly was. The fact that one looked ordinary while the other seemed to break the rules of physics only deepened the intrigue. But the universe wasn't finished surprising us. In mid-2025, astronomers detected a third interstellar visitor, and this one promised to be the most extraordinary of them all. Detected by the Atlas Sky Survey System, it was quickly designated 3I Atlas, the third confirmed interstellar object ever observed. What immediately set Atlas apart was its size, far larger than both Oumuamua and Borisov, and its unusual path into the solar system. Unlike the first two objects, which approached us head-on, Atlas was arriving from the side, cutting across the plane of the planets like a cosmic intruder from an entirely different neighborhood of the galaxy. Early observations suggested that it wasn't just another rock or shard of ice drifting through space. Instead, its trajectory, size, and likely origin pointed to something far more ancient and mysterious. The stage was set for yet another chapter in humanity's growing story. Contact, not with aliens, but with the vast, uncharted population of interstellar travelers that wander between the stars. From the very first observations, it became clear that 3I Atlas was unlike anything we had previously encountered. Its sheer scale immediately set it apart, while Oumuamua measured only a few hundred meters in length and Borisov's core stretched just a few kilometers across. Atlas appeared colossal by comparison. Estimates suggested that the nucleus alone might span up to 11 kilometers, while the glowing coma of gas and dust surrounding it could reach an astonishing 20 kilometers in diameter. That made it 10 times larger than Oumuamua and several times the size of Borisov, easily visible to telescopes even from its vast distance. And then there was its speed. Atlas was racing through the solar system at a pace far greater than its predecessors, fast enough to guarantee that nothing, not even the sun's immense gravity, could capture it. Its path was hyperbolic, meaning that just like the others, it was only a visitor, here for a brief encounter before vanishing forever into interstellar space. But what really caught the attention of Astronomers was the direction from which it had come. Rather than approaching along the familiar plane of our solar system, Atlas seemed to have originated from the thick disk of the Milky Way, a sparsely populated region above and below the galaxy's main spiral arms. Objects in the thick disk tend to be ancient relics, survivors from the earliest days of the galaxy's formation, more than 7 billion years old in some cases. If Atlas truly came from such a place, then we were looking at a fragment of cosmic history older than our own solar system, a messenger carrying information from a time before Earth even existed. Its trajectory through our system only added to the drama. Instead of a simple flyby, Atlas was poised to sweep past multiple planets, making it a kind of grand tour of the inner solar system. Calculations showed that it would come within about 28 million kilometers of Mars, a distance that sounds vast but is relatively close on astronomical scales. After that, it would swing past Venus at around 97 million kilometers and then head outward, passing Jupiter at just 53 million kilometers, a rare chance for our orbiting spacecraft to potentially observe it up close. Curiously, Earth would not be part of this cosmic encounter. At the time of Atlas's closest approach, our planet would be positioned on the opposite side of the Sun, shielded from a direct view. To some, that coincidence felt suspicious, as though the object were deliberately avoiding us. Was this just chance geometry, or could it fuel speculations about alien intent? Most scientists dismissed that notion as far-fetched, but they admitted the timing was fascinating. For humanity, Atlas represented a chance not only to observe another interstellar comet, but to study one in much greater detail than ever before. Unlike Oumuamua, which slipped away too quickly, Atlas's journey offered us months of observation time. Every moment it moved closer to the Sun. It promised to reveal new secrets, perhaps locked in its icy core for billions of years, waiting to be uncovered by our instruments. As 3i Atlas continues its journey through our solar system, the scientific community stands at a crossroads of possibility and imagination. Unlike Oumuamua, which vanished too quickly for detailed study, and unlike Borisov, which was observed but lacked the same level of mystery, Atlas offers us a precious opportunity: time. Months of close observation mean astronomers can track its brightness, analyze its spectral signature, and perhaps even detect unusual elements hidden in its coma. Every photon of light reflected from its icy surface carries a story billions of years in the making. By studying Atlas, scientists hope to test some of the most ambitious theories about interstellar objects. One possibility is that objects like this are composed of exotic ices, such as solid nitrogen, that could explain Oumuamua's strange acceleration without requiring alien technology. If nitrogen ice is confirmed in Atlas, it might suggest that these objects are fragments of distant, Pluto-like worlds from other star systems, shattered by cosmic collisions and then ejected into interstellar space. But the other, more thrilling possibility is that Atlas might reveal something completely new, something that doesn't fit into our current models of planetary formation at all. Beyond the raw science, Atlas has already sparked conversations about the future of space exploration. Many experts argue that the next time an interstellar visitor is detected, humanity should be ready to launch a rapid response probe, an automated spacecraft capable of intercepting the object and sending back direct images and data. The fact that we've discovered 3 interstellar objects in less than a decade suggests that the galaxy is teeming with such wanderers, each one a messenger from a different corner of the Milky Way. The challenge is not whether they exist, but whether we are prepared to chase them. Atlas reminds us of how small we are, yet how vast our opportunities can be. It connects us to an era long before our solar system's birth, carrying materials forged in alien suns and frozen in the silence of interstellar space. For philosophers, it raises questions of origin and destiny. Are we alone? Or are these objects breadcrumbs leading us toward other civilizations? For scientists, it is a laboratory that nature has delivered right to our doorstep, free of charge. And for ordinary people gazing up at the night sky, it is a humbling reminder that our solar system is not isolated, but part of a great galactic sea where objects, and perhaps even life itself, can travel from star to star. Whether Atlas ultimately turns out to be ordinary or extraordinary, one truth is undeniable: it is rewriting our understanding of the cosmos. Each interstellar visitor expands the boundaries of what we know, reminding us that the universe is full of wonders waiting to be discovered. As Atlas speeds toward the edge of our solar system, humanity is left with both answers and questions, but most of all, with a renewed sense of awe at the infinite possibilities that lie beyond the stars.